Good evening, sir. My topic for CAA2 assignment is intrinsic semiconductors. We move on introduction to intrinsic semiconductor. An intrinsic semiconductor is a pure semiconductor material with no added impurities. It has an equal number of electrons and holes, which allows for the flow of current under certain conditions. Intrinsic semiconductors have an energy gap band gap that determines their electrical conductivity. Move for crystal structure of intrinsic semiconductor are intrinsic semiconductor has crystalline structure with atoms arranged in a regular pattern. The most common intrinsic semiconductor materials are silicon and germanium. The crystal lattice of intrinsic semiconductors allows for the movement of charge carriers. Energy bands in intrinsic semiconductor. Intrinsic semiconductors have a valence band filled with electrons and conduction band that is empty at absolute zero temperature. Electrons in the valence band can jump to the conduction band when provided with energy, creating electron-hole pairs. The energy gap between the valence and conduction bands is known as band gap energy. Electrical conductivity in intrinsic semiconductor. Intrinsic semiconductors have low electrical conductivity at room temperature. The conductivity of intrinsic semiconductors can be increased by raising the temperature or through the addition of impurities in a process called it is doping. At room temperature, the electrical conductivity of intrinsic semiconductors is primarily due to thermal generation of electron-hole pairs. Carrier concentration in intrinsic semiconductors. The carrier concentration in intrinsic semiconductors is determined by the intrinsic carrier concentration, which depends on the temperature and energy band gap energy. The number of electron-hole pairs in intrinsic semiconductors increase with temperature due to thermal excitation. Intrinsic carrier concentration is a crucial parameter in understanding the behavior of intrinsic semiconductor. Optical properties of intrinsic semiconductors. Intrinsic semiconductors exhibit interesting optical properties such as absorption and emission of light. The band gap energy of intrinsic semiconductors determined the wavelength of the light that can be absorbed or emitted. Light absorption in intrinsic semiconductors can lead to the generation of electron hole pairs. Applications of intrinsic semiconductor. Intrinsic semiconductors are essential components in electronic devices such as diodes, transistors, and integrated circuits. They are used in photovoltaic devices to convert light energy into electrical energy. Intrinsic semiconductors also play a vital role in optoelectric electronic devices like light emitting diodes, LEDs, and lasers. Challenges and limitations of intrinsic semiconductors. Intrinsic semiconductors have limitations in terms of their electrical conductivity, which can be overcome through doping. The impurity of quality of intrinsic semiconductor materials are critical for achieving desired electronic properties. Scaling down the size of semiconductor devices poses challenges in maintaining the intrinsic properties of the material. Future trends in intrinsic semiconductor technology. Research in intrinsic semiconductor materials focus on improving their electrical and optical properties for advanced electronic applications. Emerging technologies such as quantum computing and nanoelectrics rely on the unique properties of intrinsic semiconductors. Continued advancements in material science and fabrication techniques which will drive the development of next generation intrinsic semiconductor devices. We can move for conclusion. Intrinsic semiconductors and fundamental materials in modern electronics and optoelectronics. Understanding the properties and behavior of intrinsic semiconductors is crucial for designing and optimizing semiconductor devices. The ongoing research and innovation in intrinsic semiconductor technology hold promise for future advancements in electronic and photonic application. Thank you for listening for the patience, sir.